Hi guys, and welcome to another video. And in today's video lesson, we're going to be looking at grade 12 maths algebra, challenging questions from past papers from 2010 to 2019. And this is part 4 of the series of videos. We're going to be looking at the question that appeared in the November 2015 examination paper, and it reads as follows. Question 1.2, given 3x minus y all squared plus x minus 5 all squared equals to 0, solve for x and y. In this particular question, what we have to look at is in this equation, the left-hand side, remember, must equal to the right-hand side. So we have to now basically look at this. So therefore, 3x minus y all squared must equal to 0. And x minus 5 all squared must also equal to 0. So therefore, we can now equate 3x minus y to 0 and x minus 5 to 0, and we can solve. So therefore, for question 1.2, we're going to say 3x minus y equals to 0, and x minus 5 must also equal to 0. So let us solve. So x minus 5 equals to 0 will be x equals to 5, and x is going to equal to 5, and here 3x equals to y. Now we already know that x is equal to 5, so we can now substitute and solve for y. Therefore 3 times 5, which is going to equal to 15, so therefore y is going to equal to 15. There you go. X is going to equal to 5, y is going to equal to 15. Let's look at the next question. For which value of k will the equation x squared plus x equals to k have no real roots? Now in this particular question, remember that for no real roots, delta, which is your discriminant, must be less than 0. So for once again, for no real roots, delta must be less than 0. And what is delta? Delta is equal to b squared minus 4ac. So let us firstly write x squared plus x equals to k in the standard form of a quadratic equation. So therefore, 1.3, but x squared plus x equals to k. So x squared plus x equals to k, x squared plus x minus k equals to 0. So now it's in the standard form of a quadratic equation. So therefore a is 1, b is also 1, and c is going to equals to minus k. For no real roots, so we'll write down non-real roots or no real roots, delta, which is a discriminant, must be less than 0. Therefore, b squared minus 4ac must be less than 0. And what is b? So that's 1 squared minus 4 times 1 times c is minus k must be less than 0. So therefore we have 1, and if we simplify this, it will be minus times minus is a plus, so that will be plus 4k less than 0. So we got 4k must be less than minus 1, therefore k must be less than minus 1 over 4. So the answer is k must be less than minus 1 over 4. Let's go look at the next question that I want to look at in this video lesson. So in the November 2017 paper, question 1.3, it says here, given f of x equals to x squared plus x plus 16. And we are now required to do the following. Say here, solve for x if f of x is greater than 0. So therefore, we have a quadratic inequality in the first question. So therefore, 1.3.1 Let's now go and substitute f of x. It will be greater than 0, and let's solve this quadratic inequality. So we'll have x squared plus 8x plus 16 greater than 0. So let us factorize x squared plus 8x plus 16. So what are we going to get here? Let's see. Factors of 16 when multiplied together to give us positive 16, when added together to give us plus 8. So therefore we'll have x times x there, and we'll have 4 and 4. So it's going to be plus 4 and plus 4. So what do you notice? In this particular example, this quadratic here factorizes here to be x plus 4 all squared greater than 0. Now, if you have to now look at that, remember that my critical value in this instance will be x equals to minus 4. So if I have to look at the line minus 4, so if you look at that, if we have to substitute values on either side of minus 4, you will see that you will get positive values. So it doesn't matter what you substitute here. If you have to put, for example, negative 3 here, you'll get negative 3 plus 4, and that will be a positive value. If you have to put negative 5 in here, you'll get minus 5 plus 4, which is minus 1 all squared. So basically, it's going to be positive on both sides of negative 4. So what can we conclude? Well, we can now conclude that for all values of x, it will satisfy this inequality, which means it will be positive except 2 minus 4. So x must not equal to minus 4, x element of real. So if we put, for example, minus 4 into this particular equation, minus 4 plus 4 is 0. And remember, 0 is not greater than 0. So therefore, x must not equal to minus 4, xer. Let's look at the next question. For which values of p will f of x equals to p have two unequal and negative roots? So let's go and substitute f of x equals to p. Let's see what we can come up with there. 1.3.2. So here we got x squared plus 8x plus 16, x squared plus 8x plus 16 equals to p. And we'll have x squared plus 8x plus 16 minus p equals to 0. And if we look at this now, we will have our following: a equals to 1, b will equals to 8, and our c value will be 16 minus p, 16 minus p. Now let's go look at the question one more time. It says for two unequal negative roots. Now for unequal roots, so let's do the first part. For unequal roots, for unequal real roots, for unequal roots, so we can just write that down. So for unequal roots, delta, my discriminant must be greater than 0. So therefore, b squared minus 4ac must be greater than 0. So that will be 8 squared minus 4 times 1 times c is 16 minus p must be greater than 0. So that will be 64. And here it will be minus 4 times 16 is minus 64. Minus times minus is plus 4p there. So it will be plus 4p greater than 0. So 64 minus 64 cancels. So here I got 4p greater than 0. Therefore, p must be greater than 0. So for unequal real roots, p must be greater than 0. Now let's go work out the part where we're going to have negative roots. Now for this particular part for negative roots, I'm going to now look at how this graph is going to look. So for negative roots, we're going to do it like this. So if I look at this particular function, which is x squared plus 8x plus 16, x squared plus 8x plus 16, remember now that if I want to draw this particular graph, I need to find a turning point, which is minus b over 2a, and that will be minus b is 8 over 2 times 1. So the axis of symmetry, the x value, therefore here, x will equals to minus 4, minus 4. And if we have to substitute minus 4 in this particular equation to get our y value, which will give us our turning point, it will be as follows. So we'll have minus 4 squared plus 8 times minus 4 plus 16, that will give us 0. So therefore, our turning point is minus 4 and 0. So this particular graph will look as follows. Minus 4 and 0, and the y-intercept here is positive 16. So we can write it as a coordinate 0 and 16 here, right? So this graph is going to look as follows. Now if you look very carefully, remember that you'll have negative roots here. So all the roots here now would be negative. Okay. So therefore, if you look very carefully, you'll be able to see that P must be between 16 and 0. Therefore, for negative roots, P must be between 0, y equals to 0, and y equals to 16. So therefore, now we can conclude the following. P must be greater than 0 and less than 16 for negative unequal roots. Learners, if you haven't subscribed already to my YouTube channel JL Maths, please do subscribe, share this content as much as possible, like my Facebook page Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com, and I'll catch you in the next video.